Hi, my name is Kathy Chen, and welcome to my presentation for my EDU 5110 Theory and Practice in Mathematics Education class. So I will be presenting on compensation strategies and transitioning from single-digit to two-digit factors. During my presentation, I will discuss the two math concepts and then give examples throughout the presentation to support your understanding of both concepts. So first, we have the table of contents. As I stated earlier, we will be discussing the two math concepts. The first one will be compensation strategies, and then we will be discussing transitioning from single digit to two-digit factors. Okay, so compensation strategies. Children and adults look for ways to manipulate numbers so that the calculations are easy. Compensation strategies involve the flexible adjustment of numbers by either overshooting or undershooting and then equalizing the change. Through this strategy, a problem is changed to an easier one, so adjustments or compensation is made. Compensation strategies is often used when a 5 or 50 is involved. These strategies are dependent on the numbers involved, which means that they can't be used for all computations. They are powerful strategies, especially for mental math and estimation. Compensation methods use a product related to the original. A compensation is made in the answer, or one factor is changed to compensate for a change in the other factor. So we have an example from our textbook. It's figure 12.17. We're going to have a few parts for this figure because there are multiple examples within this one figure. So the first problem is 27 times 4. The student first adds 3 to the 27. So step 1, they did 27 plus 3, which gave them 30. They did this so that it's easier to multiply 30 by 4 rather than 27 by 4. In step 2, that's exactly what they did. 30 times 4, which gave them 120. They then multiplied 3 times 4, which gave them 12. Because their 120 is 12 more than the actual answer for 27 times 4. In step 3, they subtract 120 by 12. So 120 minus 12, and they got 108. So their actual answer for this problem, 27 times 4, is 108. Figure 12.17 part 2. We see another problem here. So for this problem, it's 250 times 5. The student said, I can split 250 in half and multiply by 10. So this is what I did over here. I showed the student's work. 250 divided by 2 equals 125. We can also rewrite this as 125 times 2. We can do this because 125 times 2 equals 250. We haven't changed anything with the problem other than breaking the numbers apart. Then we did times 5, which is a part of the original problem. So we have 125 times 2 times 5. That then gives us 125 times 10, which then gives us 1,250. So our answer for 250 times 5 is equal to 1,250. We know this works because we didn't change anything with the problem. We just broke it apart. We never changed the values. We just took apart 250 and we split it in half. So that gave us 125 times 2. Um, and the student decided to do that because it was much easier to multiply 125 by 10 rather than 250 times 5. So figure 12.17 part 3, the problem is 17 times 70. The student added 3 to the 17, which gave them 20. 20 times 70 gave them 1,400. They then multiplied 3 by 70, which gave them 210. Just like part 1, the student had more than the actual answer. So they subtract 1,400 by 210, which gave them 1,190. So their answer for this problem is 17 times 70 equals 1,190. So transitioning from single digit to two-digit factors. Exposing students early to products involving multiples of 10 and 100 can benefit students in a positive way, especially as they move from single digit to two-digit factors. This focus supports the importance of place value and an emphasis on the actual number rather than on the separate digits. So for example 1, we have this problem. A scout troop wants to package 400 battery packs as a fundraising project. If each pack will have 12 batteries inside, how many batteries are the scouts going to need? So what is this problem asking? It's asking us to multiply 400 by 12. What the student did was break apart 400 and they got 4 times 100. And then they also brought down the times 12 right here. And then they regrouped it. So then they moved 4 times 12 times 100. They then solved 4 times 12, which gave them 48. And then they multiplied 48 by 100, which gave them 4,800. They did this because it's much easier to multiply 48 by 100 rather than 400 by 12. So their answer is 4,800 batteries. So be alert. Some students may simply tack on zeros without understanding why. They may say to multiply by 100, just add 2 zeros at the end of the number. And this is not true. So later on, when they do problems with decimals, that justification no longer applies. So we have to be careful when students say, just add 2 zeros to the end of the number when you multiply 100. They have to understand where those zeros come from. So to support students by working on problems where tens are multiplied by 10, such as 30 times 60 or 210 times 40 to support the thinking about larger products. After understanding that concept, shift to problems that involve any two-digit numbers, not just problems that include multiples of 10. So example 2, the problem is the parade had 23 clowns. Each clown carried 18 balloons. How many balloons were there together? So all together. What is this problem asking for? The problem is asking us to multiply 23 by 18. The student broke apart 18 and found factors of it, which they determined was 6 times 3. So then the student wrote 23 times 6 times 3. Then they regrouped it and focused the first multiplication problem to 23 times 6, which gave them 138. And then they multiplied that by 3, or they tripled it. So 414 was their answer. So they had 414 balloons all together. Another way to solve this problem would be right here, 23 times 18. This student took the 23, left it alone. Then they broke up 18 as 20 minus 2, because 20 minus 2 equals 18. They then wrote 23 times 20, which gave them 460. And then they did 23 times 2, which gave them 46. We can find these numbers, 23 right here, 20 up here, and 2 up here. We then took 460 and 46, and we found the difference. So 460 minus 46 was 414. Just like the previous method, the student also got 414. Example 2 continued. So this is another method, separated partial product problem. So the problem is 23 times 18. The student broke up 23 as 20 plus 3. They kept the multiplication sign right here. They then broke apart 18 to 10 plus 8. They then multiplied 10 by 20, which gave them 200. 8 times 20, which gave them 160. 10 times 3, which gave them 30. 8 times 3, which gave them 24. For convenience, I highlighted all of the 20 and showed us where we got that from. The 3s and where we got that from. All of the 10, where we got that from. And the 8. So we know these numbers weren't just made up. They were from the original problem. We then added all of these products. So we took the 200, the 160, the 30, and the 24. So 200 plus 160 plus 30 plus 24, that gave us 414 balloons. So just like the other two, we came to the conclusion of 414 balloons. And that is it for my presentation. Thank you so much for listening, and I hope you enjoyed it.